Hi, welcome to our session on Java data structures. In the previous session, we have completed the following concepts of stacks, queues, and array dequeues in lesson 4. And today's objective is to work out on the priority queues. So we'll take you to the priority queues. What is a priority queue? In Java, from the package java.util, we have a class known as priority queue, which can take a specific element E. So the type of elements we can hold in the queue is represented using this E. Now, what this priority queue does, priority queue implements serializable, iterable, collection, and queue. So it is a combination of all these four interfaces. Now, what do we do? So priority queue is an unbounded priority queue based on a priority heap. The element of the priority queue are ordered according to their natural ordering or by a comparator provided at a queue construction time. So what you can do is you can either order it naturally depending on the size or depending on alphabetical order in case if it is a string, or else what you can do is you can write a comparator. The comparator can check the let's say if the value is smaller than a specific value, we'll put it on the left. If the value is greater than the central node, we will put the value into the right. So that kind of a behavior is implemented using a comparator. Okay, so a priority queue does not permit null elements. So you cannot have null elements in a priority queue. A priority queue relying on natural ordering also does not permit insertion of non-comparable objects. So which means in case if you have an integer available and you are trying to put in a string in comparison with that integer, so that is not possible. We are going to get the class cast exception because both are of different types. Okay, so we are going to get the class cast exception. Now, the head of this queue is the least element with respect to the specified ordering, which means, let's say, if we have 0, let's say we start from the 0, okay? So the head of the element will be the least element with respect to the specified ordering if we are going into the natural ordering process. So 0 is going to be the node element, and all the greater elements will always be there at the right hand side in case if we are doing the normal ordering. But in case if we are doing a comparative ordering, then we can you can do that comparison and make it arranged on the left and the right. So if multiple elements are tied for the least value, the head is one of those elements. So we'll work out on this. The ties are broken arbitrarily. So we'll see how these ties work. But currently we have to quickly review the queue operations. So the queue retrieval operations include the following. You have a poll method, you have a remove method, we have a peek method, and we have a element method which can access the element at the head of the queue. So these are the four retrieval operations. A priority queue is unbounded, but has an internal capacity governing the size of an array used to store the elements on the queue. So that will be given to us using a constructor, but definitely there would be options wherein we can give our custom size and initialize the priority queue. Now it says it is always at least as it says it is always at least as large as the queue size. So as elements are added to a priority queue, its capacity grows automatically. The details of the growth policy are not specified. Now what do we have is this class priority queue and its iterator implement all of the optimal methods of the collection and iterator interfaces. The iterator provided in the method iterator and the splitterator provided in the method splitterator. So splitterator would be splitting the elements and making it multiple iterable using the condition. So we can see how it works. Followed by, so the iterator and splitterator are not guaranteed to traverse the elements of the priority queue in any particular order. So if you want the traversal in a proper order, then what you have to do is you have to sort the priority queue first, and then you will be able to get it, get the values traversed in a sorted order. So I believe this is clear. Similarly,
Yes.
this implementation is not synchronized. So if you are having multiple threads which are trying to access priority queue, it will not be accessed concurrently until and unless you make it thread safe by using priority blocking queue class. Okay, so we have to use priority blocking queue in order to make it thread safe, and the threads, multiple threads will then be able to access the priority. Now, the implementation provides big O of login time for enqueuing and dequeuing methods, offer, poll, remove, and add. Okay, so the time complexity for priority queues is big O of log n time complexity. Okay, and linear time for the object removal.
Okay.
With linear time, it means the number of objects available within your priority queue. Accordingly, it is going to be increased. And
Yes.
similarly, a constant time for retrieval of for the retrieval methods, which includes peak, element, and size. So you're always going to get that in big O of 1 time complexity. Okay. Now, so how do we have? We have the following constructors available for priority queues. We can quickly create a priority queue with an initial capacity of 11. Okay. And according to the natural ordering process, followed by, you can define the capacity. You can define the capacity, and then you can define the comparator also. Okay. So which creates a priority queue with the specified initial capacity that orders its elements according to the specified comparator. Okay. So you can also understand the comparator class, that how we can implement the comparator, and then we write our comparative equation, and accordingly the elements which we will be putting in, it will automatically be taking the condition from the comparator, and it's going to add the values into a priority queue accordingly. Now, similarly, the priority queue contain the element in the specified collection. So we can create the priority queues using the collections also. Followed by, we can create a priority queue with the default initial capacity and whose elements are ordered according to the specified comparator. So, so what we can do is, you can use priority queue and define the comparator, and whatever elements you are putting in with the initial capacity will be using the comparator in order to get the elements arranged. Okay. Similarly, you can create a priority queue containing the elements in the specific priority queue. As in case if you already have an existing priority queue, you can create a new priority queue using that. Okay. As well as we can also create a priority queue using a sorted set. So these are the constructors. 7 constructors are available with which you can quickly construct priority queues in different ways. Similarly, these are the methods which are available, where you have the add method, clear method, comparator method. Okay. Then you have contains, you have for each, you have iterator, offer, remove, remove all, remove if. So there are various categories of the methods available when it comes to priority queues. Okay. So now we can define the priority queue, and let us just quickly see how it looks like. Okay. As well as, before we get into the priority queue, I'm going to use this article also, because we're using this from the algorithms 4th edition book. Now, what do we have here is, so many applications require that we process items having keys in order, but not necessarily in full sorted order, and not necessarily all at once. Often we collect a set of items, then process the one with the largest key, then perhaps collect more items, then process the one with the current largest key. Now, what do we have here is, so as per the API, you can see that priority queues are characterized by the remove the maximum and insert operations. Remove the maximum and insert operations. So what we can do is, we have here, they have created a class which is known as max priority queue, which is going to create a priority queue. Then you have a max PQ with the integer, which can initialize the capacity. Then you can create a priority queue from the keys in an array. We can insert a key into the priority queue. we can return the largest key, we can return and remove the largest key, we can check if the priority queue is empty, and the number of keys in the priority queue. And with respect to the keys, it is the elements which we are using. Okay.
Okay.
Now what is happening? So there is a priority queue client that takes the command line argument, read the transaction from the and prints out the m largest transaction. So there is a program which we might use it for the reference. Here is a program which we'll see. So this program is top.m.java, and what it does have, it has an implementation of priority queue, which you can quickly observe here. So they converted the integer, they have read the integer from the command line, they have stored it into m, they have created a new minimum priority queue, and it is taking the element of a specific class known as transaction. Okay. They are reading the command prompt. From the command prompt, they are creating a new transaction. They are inserting that transaction into the priority queue, and they are trying to check if the size is greater than m. They are deleting the minimum. Finally, they are creating a new stack, pushing the transaction onto the stack and then printing the stack. Okay. So so what are they trying to do? They are just trying to identify the top transaction, the max transaction. Okay. Now here there are various representations, the heap definitions, the algorithms on heaps, and other different stuff, heap sort and all. Okay, so they have all together moved into a different direction with priority queues. So these are the basics of priority queues which they have implemented, but we'll follow the priority queue original documentation from Oracle Java. Okay. So what we'll do, let us just start Eclipse. And we are going to implement the priority queues. So let's write a new program. We're going to create a new Java project, and let's call it as priority queues. Within priority queues, I'm going to create a new class, and I will call it as my priority queue. I use the static stub also. Now, so what do we need to do? We are going to create a priority queue initially. Okay. So what you can directly do, you can create a new instance of priority queue. So this gives you the default priority queue. You can define, import the Java util package, and you can get your priority queue. I'm going to create PQ, and I'm going to create a new variable. Create a local variable priority queue. Now what we can do is we have a method to check system.out.println is PQ empty. We're going to check if it is empty. So we're going to call PQ dot is empty, and we are going to quickly run. Okay, so once I run, so you can see that we're going to get the priority queue, and we will get to have this answer that yes, the priority queue is empty at the moment.
Empty.
Okay.
Yes.
Now, what next we do need to do? We can define the priority queue with the initial capacity. We can create a priority queue with the comparator also. Okay, comparator with an element with a new comparator object. Okay, so I will also show you the comparator, how the comparator works. So comparator is an interface. Okay, so with the comparator interface, what exactly we can do? It takes the type of a comparator. Okay, and it does that in this way. So there are various functions available when it comes to compare. So there's a method known as compare, which has two elements. Okay, and it compares which one is greater and automatically returns it. So we can create our own comparator. We can define the comparison logic within that, and automatically it can sort our response. Okay. So how we can do it? You can create your custom comparator, and we can quickly do it here. So let's say I'm going to call a new class, and I'm going to call it as my comparator. Okay, I've got my comparator. Now I'm going to implement the comparator method. Implements comparator. And let's say I'm going to implement an integer comparator. I want to insert integers in it. Okay, so once I have created a comparator with the integer type, you can define any class. Okay, and I'm going to add the unimplemented methods. So when I add the unimplemented methods, we are going to get two elements here, integer O1 and O2, and then I'm going to compare it. Okay, which one is bigger, or depending on how do you want the response to be given back. Okay, so what I can do is I can give you some sample examples of the comparators so that you'll have a little better idea about how priority queues are used with the comparators. Okay, I'll give you some good resources also along with it, and we'll test a few examples, and then we'll use this comparator here. So let me just give you some basic comparator examples also. So we can write our own custom logic, which one is greater, which one is smaller. You can see that here we have various comparisons. Okay, so this compare method, which takes in two elements, is this one, the compare method. Okay, followed by, now we can check if O1 is greater than O2, return O1. If O2 is greater than O1, return O2, like that. So that is what we do need to implement over here. Okay, so what we can do is we can do it like this. Let's say, for example, if 01 is greater than, I'm saying 01, it's actually O1 is greater than O2. Okay, what you're going to do, else you're going to return O1. Okay, is greater, equal to O2. In case you're going to return O1, else you're going to return O2. And I can remove this return statement. So this is a basic comparison, you know, a very simple comparison, but we can define our own comparison logics in various different ways. Okay, which I'll give you some good examples. So I'll show you here. Java comparator examples. So here we do have some examples from the Oracle docs. This is the API docs, but I was actually looking for some good examples. I don't think we have any examples over here in the doc, but I'll refer this one. Let's say I'll take one article from Geeks for Geeks. So here you can see that we have got the compare method, object 1 and object 2, which is O1 and O2 here. Now here let's say there is a class which implements comparator student. Okay, and here we got two students, A and B. So what it is doing, it is trying to compare A's name with B. Okay, it returns A dot name dot compare to b dot name, and it might return a true or false or anything like that. Okay. So here's a sorted one, here's unsorted one. Then we have another compare method. I believe you can see that. So here, what are they doing? They're getting the name of the customer. They're getting the age for comparison. They're comparing it. Then they are returning an appropriate name with respect to the age comparison. Okay, like that. So there are various different examples which we can make use of. Now, so what am I going to do? So I've done a very basic simple. Let's say I've said return O1 or return O2. Now what I'll do, I will go to my priority queue now. Okay. So we can save my comparator. We can save all. Now I will go here back. So currently I was using, let's say I'm going to create new priority queue also here. I'm going to use a new priority queue. And this time, this priority queue is going to have an initial capacity along with the comparator, or just you can put in a comparator. We have both the options available. Okay. So what we can do is I've created a new priority queue, but this time I want the object of the comparator. Okay. So either I can create my new comparator here. Let's say new my comparator. Okay. And this becomes my comparator object mcom, let's say, and I'm going to create my local variable, my comparator, and I'm going to share my comparator here. Okay, so I've given my comparator and I'm going to call it as PQ1. So here I have my priority queue PQ1. So I've got two priority queues. Okay, then what am I going to do? I'm going to start adding the elements into the priority queues. Okay, so what I'll do is, let us just add up a few elements. So I'm going to add pq.add, and since it's an integer, I'm going to add, let's say 10. Okay, I'll use pq1.add. Again, I'm going to add 10. Then I'm going to use pq.add. I'm going to add 5. Then I'm going to add, sorry, pq1.add. pq1.add. I'm going to add 5. So I'm just putting in the same elements just to see the ordering process. Okay.
Okay.
Now I'm going to add pq3.add 100. Oh, sorry, pq.add 100. And I'm going to get pq1.add 100. Okay. So I've got a few elements added to the priority queues. Now what are we going to do? Either we can create an iterator, we can convert all of those into an array and print that. So what am I going to do? Let's say I'm going to call each element within the priority queue. Okay, so I'll write for, let's say I'm going to call integer element in or what we can do is we can quickly create an iterator for the priority queue. Okay, pq.iterator, we can get its iterator, pq.iter, going to create a new variable for this, and also I'm going to get pq1.iterator, and I'm going to save that into pq1iter. So we have got both the iterators so that we can traverse all the elements. Now what am I going to do? I'm going to print in both while pqiter dot has next I'm going to implement system dot out dot println okay. I'm going to print its element. Also, I'll say while pq1 iter dot has next, I'm going to print system dot out dot println, and I'm going to get pq1 pq1 iteration dot next. Okay, so we got two priority queues built here. I'm going to run them.
Yes.
And now you can see that I have got the first one. Let's say I'll print this one as system.out.println PQ priority queue. And this is going to be system.out.println PQ1 priority. Okay. So I've stated, now am I going to run it? So once I run, now you can see that the first priority queue, we got the normal ordering 5, 10, and 100. Okay. But here what is happening? Here we have got 10, 5, and 100. Okay. Because how did it happen? Initially we inserted 10. Okay.
Yes.
Then we have got 5. We compared it, the PQ1 appropriately, which one is in sequence, and we responded in that true or false in that way. So you can see that the arrangement of both of these are different. Priority Q1 has been ordered naturally 5, 10, and 100 depending on the comparative size. Okay. And PQ1 has been given in the way it has been inserted 10, 5, and 100. Okay. Is that clear?
Okay.
So in the natural ordering, the ordering gets ordered automatically depending on how you're inserting. It will automatically be sorted. But in case if you write a comparator, the sorting order will be done on the basis of the comparator you made. Got it?
Okay.
Now, so similarly, we have other elements like we can offer, we can remove all, we can retain all, we can convert them to array. Okay. And I think others are easy for you, right? I think you'll be able to implement others. So the important ones I have already done. The comparator I've already shown you. I have already shown you the iterator, which is an important one. For each loop, I have also shown you. We have just implemented that with an iterator. You can also call the for each directly. Okay.
Okay.
Now, and the offer is similar to insertion. The way we used add, you can replace the add method with the offer method also, and you can just pass in the element which you want to insert. Okay.
Okay.
I believe this is clear. Finally, they have a method to convert it into an array also. So you can convert your priority queue into an array as well, in case if you want
So
to
in
use.
offer, why it's saying Boolean?
Sorry, in offer?
So in offer, so it's saying type is Boolean.
Yeah, it gives you that whether the element has been inserted successfully or not. So it gives you true when it is inserted successfully, and it gives you false when it is not inserted appropriately. So that is why offer gives you the responses in Boolean. Okay, we already understood this yesterday, right? Because there are two types of methods. When you add, it gives you null. But if you want to avoid the conditions of null, and if you want to make it into true and false, then you use offer, because the add method might raise exception in case if the add is not done properly or the element couldn't be added. So it is going to throw an exception. But if you want to avoid the issues of exception, you can make use of offer method instead of add, because it gives you the response in true or false.
Okay.
It won't throw an exception and it won't disrupt your program execution.
Yes.
Got it?
Yes.
Cool. So that's all with respect to the priority queue.